How are you guys? Welcome back to my YouTube channel. Uh, sorry about this, guys. How are you guys? Welcome back to my YouTube channel. Today we'll be dealing with Fluidmechanics N6. And then if you have not subscribed to my YouTube channel, may you kindly subscribe to my YouTube channel and click the notification button so that you'll be notified whenever I post a new video. We've given figure 2 below shows 1000 to 1125 meter long. Here, as you can see, the pipe that conveys slime with a relative density of 0.8 from a tank of a rate. We have given that rate in meters per second watt for every hour. And then says here, study it and answer the question that follows. We have given this, as you can see, guys. Yeah, this is a chef that we call it that it's the same, it's relevant as a chef. As you can see, guys, that is what we have there. We have there the length, the diameter we have given there. So for question 1.3.2 says define the term relative density. The term relative density. What is relative density, guys? What is relative density? Relative density is the same as specific gravity, isn't it? The same as it is the same as specific gravity, whereby we know that relative density is the same as specific gravity. If you know that relative density is the same as specific gravity, remember from N5, whereby we know this is equals to the density of the substance divided by density of water. You remember this, and then this is a ratio. How can we define this? All right, how can we define this? So we can say this, as you can see, this is a ratio, guys. Density, relative density, I define as this. This is the ratio of two quantities expressed in the same units. As you can see, in the same units. So that is what we have. Remember, this is in kg per cubic second, also the per kg per cubic meter. This is also in kg per cubic meter. This and this cancels. This has no SI unit. So this is how you can define it like this. Is the ratio of two quantities. Remember, this is a quantity expressed in the same units quantities. So that is how simply straightforward. So here I've given says calculate the following. The density, there we need what? The density running fluid, density there of the running fluid. All right. This is what we have. So we have to want the density there. I don't know, but it's supposed to be 1.3. Why do they number 1.3.2.1? Okay, no problem. Their numbering is like this. Alright, so it says there, determine the density of the running fluid. Guys, you've given here our relative density, guys, is 0.8. We've given to become 0.8. So we will use this formula, guys, here. This is the density of the substance of the water, relative density or specific gravity. So if given a relative density, we know this will be of that substance. What is that substance of the running fluid, whereby it's a lime. It's a lime that we have seen there, divided by the density of what, of the water. All right, so guys, by the way, we know that, guys, we know that the density is 0,8. We've given the relative density to be 0,8. We want this there. We don't know that the density of this. Then of water, we know it's 1000. Then you multiply that, therefore this will simply equals to what? 0,8 multiplied by 1000. Then this will simply equals to 800. That is our density there. Well done like that. So question 1.3.2 says determine the friction factor of the pipe using what? Dense formula. Be aware that is dense, not chassis, dense formula, using dense. So according to the numbering system, this will be, we want the friction factor. Okay guys, we have HF. This is a density formula says HF is equal to F all V squared divided by 2GD. All right, we want this there, our friction. Make that the subject. You'll multiply that side, we'll have HF multiplied by 2GD divided by LV squared. So you can substitute what we have. What is this HF? We are given there, remember, is this is 9 meter. That will be 9 multiplied by 2 multiplied by gravity, which is 9,81. The diameter of this pipe is 9. Here is the diameter, as you can see there, is 925 millimeter divided by 1000. That will be 0,925. all right, divide this and multiply this by 2 multiply by 9, okay, so check. Now we have this, the length of this. What is the length? We're supposed to multiply by the length. What will be the length from here? This is the length, then the velocity. So the length there is 1000. You can see 1125 meter. 1025 meter multiplied by the velocity. We want now the velocity. Are we having the, what you call, we don't have the velocity. Okay, this is what I wanted you to see. You see, we become stuck because we don't know what the velocity. So guys, this formula, you can find the velocity, but will be long. So will be long, guys. Use this one. You can find the velocity, but no problem, use this one. There is this one, if I recall. Let me just, yeah, here there is this one, guys, the formula that says, again, remember there are two, that says FLQ squared over 3D raised to the power 5. You can use that. We make that the subject will be F multiplied by 3D raised to the power 5 divided by LQ squared. So let us try this one. HF, say it is 9. This one is 9 multiplied by 3. The diameter The diameter, what is the diameter is will be 0.925, right? Then we raise to the power 5. The length is 1125 divided by this length 1125 multiplied by q. Be careful there, the rate, be careful, is given to be 124 per watt hour, but supposed to be what per, supposed to be cubic per second. So you'll divide this by what, by, so that will be in hour to be in seconds, guys. The value that we have there, this value 1240, you'll divide this, remember you have 1 hour, multiply by 60 will be what, in minutes, multiply by 60 will be in seconds. So this is what you have. We punch that. Yes, you punch that on your calculator, or you can simply just put it, it is you can just do like that. You can put it as it is, there's no problem. You can put it as it is. You have 1240 divided by 1 multiplied by 60 multiplied by 60, then you square that. Yes, we have squared, and we can punch this now on our calculator. We're supposed to have that now. Our friction factor will give us 0.137. Remember, it has no SI units. It has no SI unit, so that is what we have. Then this is now determine what we want to calculate, the hydraulic gradient of the pipe using what, Chase's formula, guys. Uses Chase's formula. Uses Chase. The gradient is I, guys. Uses Chase's formula. Now using what, Chase's formula. So using Chase's formula, we know that Chase's formula says 2 like the square root of 2. Then this we divide this by what, by the friction. All right, we have this Chase's formula. Also another Chase's formula, it says q is equal to a multiplied by this type of velocity. Remember, the one that has c like this, mi. All right, this is what it's a Chase's formula. Remember, this is simply just the velocity. All right, instead of this one, we'll use the one of the Chase. This formula, we have two formulas so far that are more useful. We want consists of I. We want this gradient, that I there. So what can we do? Okay, for me, I don't have C here. Let me just calculate the value of C. She's this constant. I'll have there. Can calculate that Chase is constant. 2 multiplied by 9.81 divided by this. We did got it now, which is was 137. Then if we punch this, Chase's formula will be what, constant there. Chase's constant will be 1,967. We have this now. All right. We don't have M. Okay, C we have. Remember, here we have Q, A, multiply this by C. Okay, we have just calculated C, square root of M. We have to find M. This is what we're looking for. What is M now? M is D over 4, guys. Does not change. Still that we know. The diameter is the one, guys, of the pipe. The one that was 0.925 divided by 4. Then our M will be equals to what? To 0.23125 meter. That is our M there. All right, we have the M. the area obvious is pi, no problem about that. So far, since we have this, you can find I. Okay, we know Q, guys. We know the Q. We know Q. It was, let me just 1 2 4 divide by 60 multiply by 60. Okay, Q, guys. Okay, now we have Q. The rate of flow is area multiplied by the velocity. Q, remember it was that if you punch this actually here on the calculator, this thing here, oh, we've gone, okay, let me just write it here. Oh, this Q now, I'm just punching on the calculator, would be same as 0.344. Remember what we had before, it was 1 240 divided by 66 multiplied by 66. So if you punch this, guys, will give us this here. So this will be equal to, the area is pi over 4. The diameter does not change, we're still using that diameter 0.925. Then we have squared this, multiply by chassis is here 1,967, multiply by the square root. Then we have m there, which is 0.23125 multiplied by I. We're wanting this gradient. So what? Okay, now it's a matter of math, dividing this side by pi over 4, 0.925 squared multiplied by 1. Okay, this and this will cancel. Then also what we do on the left hand side, we also do on the right hand side. Okay, then this is what we'll have there. Those cancel. We'll be left with this here on this side. Then here we'll have the square root. This is square root of 23125 multiplied by r. Okay, guys, using the laws of mathematics, guys, if you have the square root of a b, this is the same as what? Square root of a multiplied by the square root of b. You are separating what is inside, so we can use that here. Typical, this can be the same as square root, can be the same as square root of 0.23125 multiplied by the square root of I. So yeah, this can be like that. So this will simply have this 0.23125 multiplied by the square root of I. All right. The aim is to have what? This. So you divide by this both sides. Let's see, you will divide. Guys, you punch this on the left hand side. After you've got what is on the left hand side, okay, we have this. Just punch this on the calculator. After we punch that, we divide by this, by the square root of this. So you'll be left with this now. After that, you'll take that. You'll do like that. After you've done them, remember you've divided. So guys, you know the maths. I won't go to the all details, but you're supposed to get that I if you know your maths. you're supposed to get your I to be equal. Remember, now I've simplified further for you. To get I, you'll do your maths, you'll get I to be equals to will simply equals to 0,00793. Remember, it has no SI units. This is what we have. All right, so what do we have again? The last question says the losses at the exit point of the tank. The losses at the exit of the tank here. At the exit of the tank here, not of the pipe, guys. This is a pipe here. This is a tank. This is a pipe. At the exit there, the losses there when we're entering that pipe. All I know, the losses there. Well, the losses there, we're supposed to have that's formula that says 0.5 v squared over 2g. That will be the loss that will take place there. The loss here is equals to this, the loss. So we have to find the velocity there. Then we'll be fine. Since we know the loss, let us find the velocity of q. It's called to velocity multiplied by area. We know that is area multiplied by the velocity is one and the same thing. This guy here is the same as 0,344. We want the velocity. The area will be pi over 4 into 0,925 squared. Then I divide by this, both sides. As I divide by that, I will have v to be 0,344 divided by pi over 4, 0,925 squared. Then our velocity there will simply equals to 0,513 meters per second. The aim why we calculating it, why I was calculating this, because the loss there will be, as I shown you, 0,5 v squared at that part divided by 2g. All right, then the initial we have 0.5, our velocity 0,513 squared divided by 2, gravity is 9,81. This will be 0,0067. Obvious, the loss is what head loss there. The loss will be in meat. So this is what we have. So this is how we go about dealing with this typical question. So thank you for watching, and may you kindly subscribe to my YouTube channel and click the notification bell so that you'll be notified whenever I post a new video. Feel free to share this to your fellow classmates and to like and to comment.